Hello everyone and welcome to my new course on Jetpack Compose. So in this course you will learn how to build a cryptocurrency app. So let's see what you will learn in this class. So you will learn room database for database operations, retrofit to make network calls from web to get the crypto data using JSON converter. You will also learn how to map network data from web to your own data class to room database. You will learn how to create canvas and how to build line charts and bar charts. You will learn how to set up paging so you can get predefined numbers of data at once in your list to have a smooth user experience. And you will learn how to set up Lottie animations into your project for some really cool animations. So let me demo the app. So I am going to start the app and you will see a really cool animation. So here we go. So you see that loading animation in the beginning, that's happening with the Lottie animation. So that was really cool with Lottie animation. And then we have our first screen, the home screen, in which we have the data for all the cryptos. So as we go down, you see that new cryptos are updating dynamically. So you can see that these animations are changing as we scroll down. So we are able to achieve that with the help of paging. So we have a symbol of Bitcoin and name of Bitcoin and price of Bitcoin, and then we have this line chart which represent the daily changes, and then we have daily changes in dollar, and then we have daily changes in percentage. We can click on any of these crypto and we can navigate to detail screen. So on detail screen we have the two charts, the line chart and the bar chart, and we have some statistics data regarding that crypto. So we have 24-hour high, 24-hour low and 24-hour change, and we have volume, supply and market cap. So let's see the requirement for this class. So you need Windows 10 or Mac, and you need Android Studio Bumblebee, and you also need minimum 8 GB of RAM. And also I will teach everything from scratch, but still knowledge of Kotlin would be plus, as I will teach everything in Kotlin language. So enroll in the course and let's start building this project, and I will see you on the other side. So let's start creating the crypto app. So we can click new project. Here we need to choose the empty compose activity. Click next. Give it a name. I am going to give it a crypto app. Set the minimum API level to 21. Language will be pre-selected to Kotlin and hit finish. So now the project is up and we can now build our crypto app. So the first thing we need is the database module. So for that we need to import room dependencies. So let's add the room dependencies first in the build.gradle file. So we have two build.gradle files. One is project level and the other is module level. So we need to add this into the module level. So let's go to the module level build file. And here in the dependencies we will define our room implementation. So let's do that. So we will just say room here, and here we need to add two dependencies, one for room runtime and another for capped room compiler. So let's add the room runtime. So we will say implementation Android X dot room, and you can see that it has already started to suggest the dependencies for room. So we need to add runtime. So let's add the runtime. So we can choose Android X dot room runtime 2.4.2, and we also need to add a capped for room compiler. So let's add that one also. So here we can say capped, and for this we can say Android dot room compiler. We got the spelling wrong. So room room compiler 2.4.2. So we will add this dependency, and then we need to add the plugin for this capped implementation. So let's add the plugin for capped. So here we can say id Kotlin dash capped, and now we can sync the project. So now the build is successful and we can build our database module. So let's create a package for database module. So in the crypto app, we can right click and choose new package, and we will call it data. And in this data, we can create another package for DB. So let's create another package for DB because we want to separate everything perfectly. In this DB, first thing we will create is the entity class. So let's create an entity class for the crypto. So we will say new Kotlin class, and it's going to be a data class. So we will choose data class, and here we will just say crypto. So basically this class contains all the information a cryptocurrency has, like the symbol, price, name, image, daily changes, all the things that a cryptocurrency has, that it will be defined in this data class. So to make it a data class, we need to annotate this data class as an entity. So let's do that first. So here we will say at entity, and we need to provide a name for the table. So in small braces we can say table name, and let's give it a name of crypto table. So we will just say crypto underscore table. Now we can define all the properties for the crypto class, data class. So first thing we need is the primary key. So we can set a primary key by using a at primary key annotation. So we will say at primary key. So the primary key for this crypto class is the symbol of the currency. So we will say value symbol of type string, got the caps lock. Then we have price of type double, name, which is type of a string. Then we have image, then we have daily change. So we will say daily change of type double. Then we have the percentage for daily change. So we will say daily change percentage, which is also of type double. Then we have high and low values. So we will say value high double and low of type double. And then we have value for supply. So we will say value supply also of type double, question mark. And then we have chart data, which will be used later. So chart data, which is going to be of type float, and it's going to be in a list. So let's say list of type float. So you see that there is a question mark at the right of the double in this supply value. So we use question mark to avoid exceptions. It is a safe cast operator which returns null in case of failure. So in case if this supply does not have any value, then it will return null and it won't fail the app. So that's why we have the question mark. And then we need to serialize this whole data class. So for that we can say here colon serializable, and here we can override the function of equals. So we can say override fun equals. So we got the override function here, and here we need to return not the super, but we need to return this crypto. So we will say return, and we will just pass this other parameter that we have, and we will say other as crypto, and then we need to uniquely identified a crypto. So we will say dot symbol equals symbol. So we need to serialize data class whenever we transfer data over a network to store data in a database or in a file. So what the serializable does, it convert data used by an application to a format that can be transferred over a network or stored in a database or a file. So that's it for this lecture, and I will see you in the next one. So next we need an interface to query the data from the table, but let me first correct this package name to DB. So let's refactor it and let's rename it to DB. Now we can create our interface. So let's create an interface. So we can go to new Kotlin class file, and here we need to choose interface. Let's call it DAO because it's a data access object. We need to annotate it with DAO. So let's say at DAO. Here we need to define a query to fetch all the crypto data. So let's do that. So to do that, we need to say function get cryptos, and it's going to be of type live data. So we will say live data. Then it's going to be a list. So we will say list, and then it's going to be a type of crypto. So we need to bring our crypto data class. So we will say crypto, and we need to annotate it with transaction because it's a transaction. So we will say at transaction, and since this is a query, we need to define a query also. So we will say at query, and inside this query we can run the database query. So here we will say select asterisk from, and here we need to bring our crypto table name. So we define the table name here, crypto table. So we need to bring in this. So we need to bring this in to the DAO. So we will say from crypto table. So you can see that it is able to fetch the table name from the data class. So basically live data is a data holder class that can be observed within a given life cycle. Its job is to observe the data and notified about modification of the wrapped data only if the paired lifecycle owner is in active state. So that's it for this lecture. Now we need a class for a list type converter, so we can convert the data from string to float because the data we get from the network is in string format and we need to convert in float type. So let's create another class. So we will say new Kotlin class, and here we will say list type converter. So inside this class we need to create a companion object. So we will say companion object, and here we will create a function to convert a string to float type. So we will say function getting float list from string, and here we need to provide a parameter. So we will say float list of type string question mark, and then it's a list. So we will define it as a list So we will say list, and then we need to convert it into float. So we will say float question mark. Then we need to annotate this function as a type converter. So we will say at type converter, and we also need to annotate it with JVM static. So we will say at JVM static, and then inside this function we can create our list. So we will say value list of type array list of. So we will say array list of, and here we need to provide the typing again. So we will say float, then we will say value array, and we will pass the float list question mark dot split. So inside this function we will say we need to provide the regex. So we will say comma, and then we will say dot to regex, and then we will say dot drop last while. Here we need to provide the question mark. So basically this split function is split this character sequence to a list of a string which matches of the given regular expression, and this drop last while function, it return a list containing all elements except the last elements that satisfy the given predicate. So here we need to say it dot is empty. So we will check whether it is empty or not, and then we will say here question mark dot to typed array. So to typed array, which returns all the array of this collection. Then we can run and if else statement. So we will say if array dot is null or empty. So we will check whether it's null or empty. Then we will just say return null because there is nothing. If the array is not null, then we can run a for loop. So we will say for s in array, and in this for loop we can run another if else statement. So here we will say if s is not empty, we are just double checking here whether it's empty or not. There we will say if s is not empty, then we can add this array to our list. So we will say list dot add, and here we will just pass our s variable, and we need to convert it to float. So we will say s dot to float, which will convert this string to float, and then finally we can return this list. So we will say return list. Now we can create the database finally. So we will say here new Kotlin class, and here we will just say database of type file. And now that we have our list type converter, we can annotate our DAO with type converters as well, because this is from where we get all the data through this function get cryptos. So here we will say at type converters. So here we will say abstract class, and we can provide the name for the database. So we will say crypto database, and its type of room database. So we will say room database. So let's annotate this class with database first. So we will say at database, and here we need to provide the entities. So for entities we can say entities, and here we can provide the arrays of entities, but list of entities, but we only have one entity, which is our crypto class. So we will just provide that one. So we will say crypto class. Then we need to provide a version number for our data class, for our database. So it will be 1 because it will be the first iteration of the database. And we have an optional argument, export schema. We can set it to false. And we also need to provide our type converter. So we will say at type converters, and here we need to provide the class of type converter. So it's list type converter that we created earlier, and again we can say class. Inside this abstract class, we need to create an abstract function, because abstract class can only have abstract function. So let's create abstract function crypto DAO to import the DAO or to get a reference to the DAO. So we will say crypto DAO of type DAO. Then we need to create a companion object. So we will say companion object. Here we need to create an instance for our database. So we will say private var instance of type crypto database. Set it to null. So in the beginning the instance will be null, and then we need to create a lock value also. So we will say private value lock, and it's going to be type of any. Any is the root of Kotlin class hierarchy. So every class has an any superclass, and every Kotlin class has any as a superclass. So now we just need to create a function to initialize the instance and create a database. So we will say function get instance, and it require a context parameter. So we will say context of type context equals instance question mark colon, and here we need to call a synchronize function. So we will say synchronize, and as you can see that it requires a lock argument. So we have already created that lock value, so we will just pass that. So we will say lock, and then we can open the curly braces, and here we need to say instance question mark colon, and we need to create a function for building the database. So we will say just build database, and it requires a application context. So we will say context dot application context. So let's just first create this function build database, and then we will come back later for this function get instance. So we will right click this red bulb and create function build database. So we can click it, and here we can choose either application context and or context. It does not matter as it is just a variable. So we will say context, and we need to choose context, and now we need to implement the function. So let's do it. So we need to remove this question mark actually, and we need to set it equals, and here we will say room dot database builder, and here we need to pass the context again. So we will say context dot application context, and after that we need to pass the database name. So we will just say crypto database class dot java, and then finally we need to pass the third argument for database name. So we can just say crypto.db, and then we need to finally call the build function. So we will just say dot build. Now we can get back to the get instance function. So here we will say, after this block we will say dot also. So in this also block we just need to set the instance to it, and it just return the instance, which means it just return to whatever you pass inside this also block. So we can just say instance equals it, and that's how it will initialize the instance. So now we need to create our network module. So let's close all of these tabs, and let's create a new package for a network module. So we will just right click, new package, and we will say network. So in this network module, first we need to create a API response. So let's create a file, and we will say crypto API response. So what is this API response? So basically we need to fetch the data from API using same data field as that in the API. So I will just show you the site of the API so you will understand it better. So this is the website for the API, and you can see that there are a lot of fields. We have ID, symbol, name, image, current price. So there are a lot of fields. We won't fetch all of these fields, but we will fetch some certain fields, and for that we need to create a data class in form of API response. So that data class should match all the data fields in this API from this JSON format. Otherwise we won't be able to fetch the data from the API. So that's why we need another similar data class, but for the network module, not for the database. The data class that we build in the database module is for our room database, and this one will not have anything to do with that data class. So let's build the API response using these data fields. So here we will say data class, and we will say crypto API response. So here we don't need to annotate it with entity, because this one is not for room database, it's for the network module. So let's create our data fields matching with the API. So we will say value ID of type string, then value symbol of type string, then we have name, also type of string, and we have image string, then we have value current price, current underscore price. We need to exactly match with the API, otherwise we won't able to fetch the data. Current price will be of type double. Then we have a market cap, so we will say value market cap, which is of type long. Then we have total volume, also of type double. Then we have those two variables which are called high 24 and low 24, which is highest value for the last 24 hours and the lowest value for the last 24 hour. So we will say value high 24 hour, so it will be just 24h of type double, value low underscore 24h double. Then we have a price change for 24 hour, so we will say value price change underscore 24h, which is also of type double. And then we have a price change percentage for the last 24 hour, so we will say value price change 24, and here we can just include percentage, so we will say percentage. And we will have two more variables, two more values for total supply, so we will say value total supply of type double. And lastly we will have the spark line in 7D, so we will say spark line underscore in 7D, which is going to be of type line data, which we will just create shortly. So we will say line data. So let's create this data class for line data. So we will say create class line data, extract to separate file. No, we want to have it in the same file, so we will say crypto API response, and it's a data class, so we will just add data here, and then we can remove these curly braces and put some small braces, and it's going to be of type float because it's just a price, so we will say value price, and it's in the form of list, so we will say list, and then we can provide the type, so we will just say float. So this spark line in 7D is used for the chart data that you have seen in lot of cryptocurrency apps, so that is where it's going to be used. So we will map in another class to something else, but for now we have to use the same keyword as it is in the API. So that's it for this lecture, and I will see you in the next one. So now we will create the mapper class which I was talking in the previous lecture. So in this mapper class we will map the crypto API response with the crypto data class. So let's create the mapper class. So we can say new Kotlin class, and it's going to be a class, so we can say API mapper, and here we need to just map the two data classes from network to room database. So we will just say function map, and we need to bring in the crypto API response data class, so we will say crypto API response, and then we need to set it to crypto data class, which is the room data class, so we will set it to crypto, and then we just need to set all of these data fields. So first we will set the name, so for name we can say crypto API response dot name. Then we are just going to map all the data fields, so just follow me. So symbol equals crypto API response dot symbol, then we have price, and here it's current price, so that's why you see that there are some differences, so that's why we need the mapper class. Hope it's getting more clear. Then we have image, then crypto API response dot image, then we have daily change, crypto API response dot price change 24, then we have daily change percentage, so We have percentage as well, price percentage, price change percentage. Then we have high and low. For high, we can say crypto API response dot high 24. Then we have low, crypto API response dot low 24. Then we have volume. I think I have missed the volume in the crypto data class. Let's try one more time. No, I don't have, so I need to correct it because I think I have forget. So let's go to our crypto data class and let's add a volume here. I have forgot the volume, so we will say volume of type double, and let's get back to our API mapper class. So we will say volume equals crypto API response dot total volume. Then we have supply, and for supply we have total supply field. Then we have market cap. Seems like I have also missed the market cap data field, so let's add that as well. Where should I add it? Let's just add below the volume. So we will say value market cap of type long, and let's get back to mapper, and here we will say market cap equals crypto API response dot market cap. And then lastly we have our chart data. So for chart data we have already talked about it, which is the Spark line data in 7-day dot price. So this price field we are extracting it from the line data because it's a list of prices, and that's all. So now we are done with the mapper class. Now the next thing we need is an interface to create repositories. So let's create another package for repositories. So we can say new package, we will call it repo, and here we need to create an interface where we can create our functions. So let's create an interface. So we will say Kotlin class file, and here we need to select interface, and we can call it crypto repository. So we will say crypto repository, and it's going to be just two suspend function, one for getting the crypto pages and another for getting the crypto data. So we will say suspend function get suspend function get crypto pages. So we will say get crypto pages, and it's going to require two arguments, one for page which is going to be of type int, and another for page size. So we will say page size, which will be also of type int, and then it's a list. So we will say list of type crypto. Because this data is so big that we cannot run on a regular function, so we need to use suspend function, because suspend function runs in background, and so the app can run smoothly and it won't freeze the UI of the app. So that's why we use the suspend function. And then we need another suspend function to get the crypto data. So we can say suspend function get crypto data, and this one is going to be of type live data. So live data, and it's again a list of data, so we need to use list, and then we need to provide the data class of crypto. So these are the two functions which will be required to fetch the data from the API. So now we need to create a network object to create a retrofit client. So let's do that. So we will do that in our network package. So we will say new Kotlin class, and here we need to select the object and we can call it network. In this object class, we need to create two constant value for timeout and for base URL. So we will say private const val, we will say timeout, and we will set it to 20L. Then for base URL, we need another constant value. So we will say private const value, and we will say base URL. So we are going to use the same URL that I showed you earlier. So let's grab the initial URL. So this is going to be from HTTPS to v3. So we will copy this URL from here until here. So this is going to be our base URL. And then we need to create an OK HTTP client. So for that we need to add some dependencies. So I will just open the build.gradle file and I will paste the dependency there, because there are a lot of dependencies and one typo mistake can fail the project. So I'm just going to paste it here. So there goes retrofit, and then we need to define the bomb. So here goes bomb, and then we need OK HTTP dependencies. So here is OK HTTP, and we need a dependency for JSON converter. JSON converter is actually part of retrofit, and now we can sync the project. So now the sync is complete and we can get back to our network module or network object. So now we need to create a OK HTTP client. So we will say, so we need to say private val OK HTTP client by lazy, and now we need to initialize the OK HTTP client builder. So we will say OK HTTP client dot builder. Then we can say apply. Here we need to make it a function. So here we need to define the read timeout and the connection timeout. So let's do that. So we will say read timeout, and we can set it to our timeout value. And then we need a second argument for the duration. So we will say time units dot seconds. Then we need to define the connection timeout. So we will say connect timeout, and we can give it the same value of timeout, and we can also give it the same time units of seconds. And then here we can build it. So we can say build. Now we need to create a value for retrofit. So let's create our retrofit value. So we will say private value retrofit, and we can bring in the retrofit. So we will say retrofit dot builder, and then we need to provide the client. So we will say client, and for client we are going to use our OK HTTP client. So we will say OK HTTP client. Then we need the base URL. So we will say base URL. So we will provide the base URL, and then we need to add a converter factory. So we will say add converter factory, and for that we can use our JSON converter factory. We will say JSON converter factory, dot create, and then we can finally call our build function. So we will say dot build. Now we need to create a function for repository, so we can create repository. So we will say function create repository, and it requires a context. So we will say context, and it's going to be of type crypto repository, the interface that we created. So we will say crypto repository, and here we need to get an instance of our database. So we will say value db crypto database dot get instance, and we can provide the context for it. So we will say context, and now we need to create a crypto repository implementation, because we just created these functions, but we did not created their implementations. So we need to create those. So in the next lecture we are going to create implementations for the crypto repository, and then we can come back to our network object. So I will see you in the next lecture. So to create our crypto repository implementation, first we need to create an interface for our crypto API. So let's create our API first. So we need to create another package in the network module. Here we will call it Kotlin class, and we need to select the interface, and we can call it crypto API. So in this interface we need to define endpoints for our network calls. So let's define our get point. So to define a get point, we say at get from retrofit, and here we need to provide the value for it. So when we define our base URL, it was only until here, and after this v3 we had a very long endpoint. So we need to define that endpoint in our crypto API. So let's do that. So I'm just going to paste it. So I will paste the endpoint. So this base URL and this endpoint together, they build the whole URL. Together they build the complete URL. And then after that we need to define our suspend function for get all cryptos. So we will say suspend function get all cryptos, and then we need to define a query for it. So we will say at query, and then we need to define the page or provide the value for page. So we will say page, and then we can create a page variable of type int, and we can set it to 1. Then we need another query. So we will say at query for how many items we are going to have per page. So we will say per page, and for this we can say page size, which is also going to be of type int, and we can set it to 20. So on every page we will have 20 crypto datas, and then we need to set it of type. So we will say response, because it's type of response, and then we need to provide the list, because it's a list of data, and then we can provide our actual API response class. So we can say crypto API response. Now we can create the crypto repository implementation. So let's do that. So we will say class crypto repo implementation, and here we need to bring in the API DAO and API mapper. So we will just say private value crypto API, we will say crypto API of type crypto API. Okay, we need it as an argument, so let's make two small braces, and here we can define these. So next is DAO, so we will say private value DAO, and we need to select our own created DAO, and then we need the mapper class, so we will say private value API mapper, and this implementation is type of our crypto repository interface, so let's bring that one as well. So we will say crypto repository, and now it's required to those two functions, so we will just say implement members, and we need to implement both members, so we can just click OK. So let's implement these two functions. So we will remove the to do, and here we need to create a response. We will say value response, and to get the response we need to get the response from the crypto API. So we will say crypto API dot get all crypto, and we can provide the page as an argument, so we will say page. Then we need to see whether this response is successful, and it's either null or not empty, so we will say return if, and here we will learn some if and else statement. So we will say if response dot is successful, and we also need to see whether this response has some data or not, so we can say and response dot body, and we can call the function is null or empty, so we will say is null or empty. And now we have to check whether it's null or empty, so we can bring in the exclamation mark at the beginning, so it will become not null or not empty. So if the response is successful and if the response body has some data, then we can say, then we can create another API response list. So we will say value crypto API response list, and here we will just fetch the response list from the response body, so we will say response dot body. Then we need to create our crypto list, so we will say value crypto list, and here we need to map our crypto API response list to API response, so we will say crypto API response list question mark dot map, and here we can say crypto API response followed with an arrow function, and then we can bring in our mapper, so we will say API mapper dot map, and here we can map our crypto API response, so we will say crypto API response. After that we will return the crypto list, so we will say crypto list. So if the list is not empty, so to check whether it's empty or not, we can say question mark colon empty list. So if it's not empty, then it will return the crypto list, otherwise we will just return empty list. So here we need to say empty list, and we need to annotate it with worker thread, so we will say add worker thread. So we need to annotate it with worker thread because so it can do all the processing in a separate thread, so it won't be able to interrupt any changes that occur on the UI thread, so that's why we separate it to worker thread. Now we need to implement this suspend function to get the crypto date. Actually it's data, but I think I had a typo mistake, so let's correct that first. So we can say refactor and we can rename it. So we will just say we need to choose rename base function, and here we will just say data, not date. So to implement this function, we just need to set this function to our DAO. So we will say DAO dot get cryptos, and that's it. We are done with the crypto repository implementation class. So let's get back to our network object and complete our repository function, create repository function. So here, after getting the instance of DB, we can say return crypto repo implementation. We need to provide these three arguments. So we will say crypto API, which is the first argument, and for that we can say, and to get crypto API we can use our retrofit client, and we can say dot create, and we can use the crypto API. So we will say crypto API class dot java. Then the second argument is our DAO. So we will say DAO equals db dot crypto DAO, and the third argument is our mapper class. So we will say API mapper, and we can set it to API mapper. So now our network object is complete. So now that we have completed our network module and our database module, now it's time to create our UI. So we will build two screens, a home screen and a detail screen. So to do that, first we need to create a view model class for our home screen. So a view model is designed to store and manage UI related data in a lifecycle conscious way. It allows data to survive configuration changes such as screen rotation, and so all the business logic go inside the view model and the UI related things stay in our home screen. So in this way we separate the UI components from the business logic. So to create our view model, we first need to add the dependency for view model. So let's add the dependency for view model. So we can go to build.gradle file, and here we will say view model, and then we can say implementation Android X dot lifecycle, and we can choose the lifecycle view model from the list if it shows. So there we have the view model compose, and let's sync now. So now the sync is complete. So let's close all these tabs and let's create another package for screens. So we will say new package screens. In this screen we will first create view model. So we will say new Kotlin class, and we will say home screen view model. So first we need to create a factory class that can provide scope for view model. So let's create our factory class first. So we will say class home screen view model factory, and it requires a context. So we will say value context, and which is type of view model provider. So we will say view model provider. So this view model provider is the utility class that provide view models. for a scope, and we need to import the context. So alt plus enter. So after view model provider, we can say dot factory, and then we can open the curly braces, and here we need to override create function for model class. So we will say override function, and now we need to implement this factory class. So we will say return home screen view model context as t. Now we need to add this argument to our home screen view model. So we will say here context, and then it's a view model, so we will say view model, and here we need to create a value for our crypto repository from the network object. So let's go back a little bit. So we need to call this create repository to create the repository. So we will say private value crypto repository of type crypto repository, and here we will say network. So we need to select our network object, and then we can say, we can call that create repository function, and we need to pass the context as well. So we will say context. Now we need to create a function to get all cryptos. So we will say function get all cryptos, and here we need to provide parenthesis to pass the page size. So we will say page size of type int, and we can set it to 20. So in one page we will have 20 crypto data, and then we can set it to pager. So we need to add the dependency for pager. So let's add that. So go to the build.gradle file, module level, and here we can say paging, and we can say implementation, and we can say Android X dot paging, and we need to select the compose paging. So we will say paging compose, and we can go actually one version backward because the alpha 15 is the latest one. It can contain bug, so we will use the alpha 14, and let's sync now. So now the sync is complete, and we can get back to home screen view model, and let's import our pager. So we will say pager, and it requires a key value pair. So we will say, so let's first provide the configuration for it, paging configuration. So we will say config, and it requires paging configuration. So we will say paging configuration, and here we need to provide the page size and initial load. So for page size we can say page size, and we can set it to the page size argument that we created here, and we also need to give it a initial load. So for that we can say initial load size, and we can also set it to our page size. So it will be 20. Let's increase the screen size a little bit, and then we can open the curly braces, and here we need to create a source for page number. So we will do that in next lecture. So let's create our page num source class. So we can create a new package, and we can call it utility. We can call it util, and let's create our class. So we will say new Kotlin class, and we can call it page num source, and let's give it a value of any type. So we need to say value of any, and then we need a value for load page. So we will say here private value load page to load the pages, and it's going to be a suspend function. So we will say suspend, and here we can provide two variables again for page number and page size. So page num is going to be of type int, and page size will be also of type int. And then we can create an arrow function for list. So we will say arrow function list, and then we can pass our value here. So we will say value. After that we can say paging source. So we will say paging source, and it requires two key value pair. So we will say int. The first one is the type of source, and the second one is the value itself. So we will say value. And now we need to implement these member functions that we created. So we will say implement member, and it has two members, get refresh key and load. So we need to implement both. So let's do that. So let's implement this load function first. So we will remove this to do, and we can say return, and we can run a try catch block. So we will say try, and we need to create two values, one for page and one for result. So for value we can say value page equals params dot key question mark. So here what we will do is we check if there is any key. So if there is any key, then we will set it to the key, otherwise we will set it to the 1. So it will be first page, and we need a value for result. So we will say value result, and for result we can say load page. So we can call this function load page, and we can say page, and we need to pass the load size. So we will say params dot load size, and then we can also say that if there is no result or if there is no data, then we can also say return load result dot error, and we can pass an exception. So we can say EOF exception, and we can just say no data. Then we can set our load result. So we will say load result. So we will say load result dot page, and let's provide the data. So it requires a data. So we will say data equals, we can set it to the result that we get from this value, and then we need to set two key, one for previous key and one for next key. So we can scroll up and scroll down. So we can say previous key, and we can set it to, we can check an if else statement. So we will say if page is equals to 1, then previous key we will set to null, because you cannot go back because you are already on the first page. Otherwise we will say, else we will say page -1. So if we are on second page, then we can go back by decreasing one value, and then we need to create our next key. So for next key we will say page dot plus 1. So we will just increment it by 1, and then we need to run some catch block. So we can say catch, and we need to look for some input output exceptions. So we will say E of type IO exceptions, and we will just return the exception if we found any. So we will say load result dot error, and we can pass our parameter E, and we need to also look for HTTP exceptions because we are getting data from network. So let's also put a catch block for HTTP exception. So we can say catch E of type HTTP exception, and here we will return HTTP exception. So we will say return load result dot error, and we can pass our E parameter. Now let's build our refresh key function, get refresh key function. Its job is to find the page key of the closest page to the anchor position. So we will say, we can remove this to do, and we will say return state dot anchor position question mark dot let, and we can create a variable of anchor position followed by arrow function, and we can run a function to set the previous key and next key. So here we need to create a value for anchor page. So we will say value anchor page, and we can set it to state dot closest page to position, and we can set it to our anchor position variable, and then we can say anchor page question mark dot previous key question mark dot. So we can say plus, we will just increment it by 1, and for the next key we can say question mark colon anchor page question mark dot next key question mark dot minus 1. So depending on the scrolling behavior, whether we are going down or whether we are going up, we will increment or decrement the anchor page by running this function get refresh key. So it will automatically refresh the pages. So in the next lecture we will get back to home screen view model. So let's get back to home screen view model, and now we can bring in the page num source class. So we will say page num source. We can create two variables. So we will say page num and page size followed by arrow function, and we can run this function from crypto repository. So we will say crypto repository dot get crypto pages, and we can pass our page num and page size variables, and then we can call the flow function. So we will say dot flow, and we can say cache in, and we can provide the view model scope because it requires a scope. So we will say view model scope. So this flow API is a type that can emit multiple values sequentially, as opposed to suspend function that returns only a single value. So flow just provide a better way to handle the stream of data asynchronously that executes sequentially. So flow emits value as soon as they are done computing them, and it consists of producer and consumer. So the producer emits value while the consumer receives the value. And now we need a value to get the crypto data. So we will say value crypto live data, and we will use live data. So we will say live data, and for that we need to actually add the dependency for live data. So let's do that. So we will go to build.gradle file, and here we will say live data, and we will say implementation Android X dot life cycle live data ktx, and now we can sync. So now the sync is complete and we can bring in the live data. So we will say live data, and we can remove this, and here we will say dispatchers, and we will select the Kotlin dot coroutines. So we will say dispatchers dot io, and then we can say emit source, and here we will say crypto repository dot get crypto data. So I guess that is the end of our home screen view model. So from the next lecture we will start building our home screen. So I will see you in the next lecture. So now we will build our home screen. So I will show you what we are going to build. So this is the screenshot of the home page. So in that we have a header which just contain a text of crypto listing. Then we have the list of all the cryptos. So we have this icon or symbol for the Bitcoin, and then we have the name for Bitcoin and its current price. Then we have this chart or graph which basically shows that whether its price is increasing or decreasing. And then we have this price change in dollar, and then we have this price change in percentage, and then lastly we have this favorite icon which does not do anything at this point. So we will start building with our crypto listing header. So let's get back to studio and start building this home screen. So we will close all of these tabs and we will create new screen. So we will say new Kotlin file, and we will select file and we'll say home screen. So here we will create our first composable function. So let's say add composable, and we will say function home screen, and in this function we need scaffold. So we will say scaffold, and then we can bring in a column. So column is basically a vertical layout. So we will say column, and then in this column we need a modifier to fill the max size. So it will take the entire screen. So we can say modifier equals modifier dot fill max size, and here we need to create another composable function for our header. So we will just say header, and it will give me a red sign. Yeah, so we will just say, so actually there is something related to retrofit. So that's why it's saying to import the retrofit header, but we are actually creating our own header function. So we will not import this function, and we will rather create a header function, a separate header function here. So we will say add composable function header, and this should remove the red lining. So it has already removed the text in red. So you see that this text crypto listing is taking an entire row of the screen. So we can create a row for this text. So let's do that. So here we will just say row to create a row, and we can set some modifiers. So we will say modifier equals modifier dot fill max width. So it will take the entire width, and let's give it some padding. So we will say dot padding, and we will give 8 dp of padding. Let's import the dp, and because we have given the entire max width, we don't want to give it all of the height, otherwise we won't be able to show the crypto data. So we will limit its height by saying dot height, and we can set it to 25 dp, and then we can make the text in center by saying arrangement dot center. So the text will be arranged in center, and now we can create our text here in the row scope. So we will say text, and here we can simply say crypto app, whatever you want to call it, it does not matter, it's a hard coded text. And then we can style it. So we can say style, and we can give some typography and font. So let's give it a typography of H3. So we will say material theme dot typography dot H3, and we can give it a font size also. So to do that, we can say font size, and here we can say 18.sp. Let's import the sp as well, and we can also give it a font weight. So we can say font weight, and let's give it a semi bold font weight. So we will say font weight dot semi bold, and I think that should do for our header. So let's call this home screen function in our main activity to see if everything is working correctly, because we have not run our app yet. So we will just remove this greeting, and we will say home screen, and I am going to start my emulator to see if it's running properly or not. So it's gonna take some time, and we have a failure and our app did not start. So we got the error, cannot configure how to save this field into database. You can consider adding a type converter for it, chart data. So we have some problem with our chart data. So let's see our crypto data class. So chart data looks fine, and maybe we have some problem with our type converter. So let's go to that. Okay, so here I actually forget to add another function to convert string from float, because we have one function to get data from string to float, but we need another function to convert float to string, because room does not support the ability to store list directly, and it does not have the ability to convert from the list. So we need two functions to convert the string to float, and then when we need to display the data on the screen, then we need to convert again from float to string. So let's add another function here. So after this function we will say, so here we will say add type converter and add JVM static, and here we will say function writing string from float list, and it's require list because we already have float list. So we will say list of type list, and there we will say float question mark, and it's going to be of type string because we are converting to string. So we will say string, and then we will open the curly braces, and here we will say var IDs, and then here we will say double quotes, so it will be empty in the beginning, and then we will say if IDs is empty, then we will return null, and if it's not empty, then we will say else. We will run a for loop and we will say for I in list. So we will pass the list argument from the function, and then we can say IDs plus equal, and then we will just pass the I in list. So we will say $I, and here we need to actually provide exclamation mark 2 times, and after that we can here say return IDs. So we will say IDs, and now we should run it again, and this time everything should be okay. So let's run it. So now the app is up and running, and you can see our header crypto app. So you must be wondering that the screenshot that I showed was in black color, and that's because that was taken from my physical device, and this emulator API level is 27. So you can see that here from device manager. So API level 27. So it does not have dark mode available at this API level. So that's why we are seeing this in different background color and different text color. But if you run on latest Android devices, and if that has the dark mode enabled, then you will get the same fill as I shown in the screenshot. So that's it for this lecture, and in the next lecture we will be building the list of all the cryptos. So I will see you in the next one. So now we will build this list item. So basically it's just one component with a row, and in that component we have our icon and Bitcoin name and price and this chart data and this daily price change and daily price percentage and this favorite button or icon. So this is just one component. So we will build this one component, and then we will use lazy column to reuse this component over and over again to fill all of these different data. So let's build this component. So I am going to close this converter and this crypto class, and we need to create another package. So we will say new package and we will call it components. So components, and we will create a new Kotlin file and we will say it crypto list item. Actually we needed the file, not class. So I am just going to remove this declaration, and I will just say at composable function crypto list item, and it's going to require some parameters. So the first parameter will be the crypto data itself, because that is the one that fills all the data into our this list item. So we will say crypto of type crypto, and we need to select the data class. Then we will have the is favorite icon. So we will say is fav, which is going to be of type boolean, and we can set it to false in the beginning. And we will have another parameter for it, but we will add that parameter later. Right now we don't need that parameter, so we will talk about that later. So let's open the curly braces, and here we need to create a context first. So let's create it. We will need it context, and we will say local context dot current. We need to import the local context, and then we can say current. So we need to create a row first, so we will say row, and we need to add some modifiers, so we will say modifier equals modifier dot fill max width, so it can fill the max width. Then we need to make it clickable, so we will say dot clickable, and we can select the second one, and we will say on click. So for now we can leave this on click function empty, so it won't do anything, but we will later add function in this on click method, so we will leave it for now. And then we need some padding, so we will say padding, and let's give it a 16 dp of padding from all sides. Let's import the padding, and we need horizontal arrangement, so we will say horizontal arrangement, and we can say arrangement dot space between, so it will be spaced evenly between all the subcomponents. And then we also need the vertical alignment, so we will say vertical alignment, and we can set it to center vertically. Now the first item is this image, so because we are fetching this data from the web, we need a image loading library, so for that we will use coil image loading library. So let's add the dependency for coil image, so we will go to build.gradle file again, and here we will just say coil image, and we will say implementation io.coil -kt, then we will say colon coil -compose, and then we can provide the version for it, so we will say 2.0.0, and let's sync the project. So the sync is successful, and we can get back to our crypto list item. So here we will say async image, so the coil image is named as async image, so we will say async image, and it should appear in a moment. So there you go. So there we have async image, the image loading library, so we can choose the first one, and it requires a model. So first we will say for model image request, because we are requesting an image, so we will say image request dot builder, and this builder is required a context, so we will pass the context that we created earlier, so we will say context. Then we can provide the data, and for data we can simply say crypto, so we will use the crypto reference from our crypto data class, so we will say crypto dot, we can pass the image, then here we can say dot build. For content description we can simply just pass null here, and now we need to add some modifier to the image, so after content description we will say modifier equals modifier, and first we need to set a size for it, so we will say modifier dot size, and we can give it a size of 40 dp, so we will say 40.dp. Then we can give it some padding also, so we can say dot padding, and we can give it a padding of 4 dp from all sides. And then we need to provide a content scale for it to scale the image, so we will say content scale, because the image is very small we need to crop it, so we will say content scale dot crop. So we will get the nice small icon for the crypto. So that's it for the image. And the next thing is that we have this name of the currency and the price of the currency. So you notice that it's actually two data. So how you can fit two data in a vertical fashion in a row? So what we can do is we can add a column after this component. So we can add a column here. So we can put data in a vertical fashion. So let's do that. So for that we can just simply create a column here. So we will say column, and again it's required some modifier. So we will say modifier equals modifier, and we need to give it some weight because otherwise it will take the entire row space. So we need to provide weight for it. So we will say weight, and we will just give it 0.3f weight 3f. So it will just take enough to fill those two items. So the first item is the name of the crypto. So for that we can say text, and for text we can just simply say crypto dot name, and we can style this text. So for that we can just say style, and we can say material theme dot typography dot h6. You can choose anyone of your liking, and then we can also give it a font size. So we will say font size of 16 sp, and we need to import the sp, and we need to add some padding. So for that we can simply say modifier equals modifier dot padding of 4 dp. So after this text name we have the price. So we will just simply copy this text component, and we will just paste below it, and we can just change the data for this text. So we will say crypto dot price, and we can leave the rest as it is, and we have some error. So it says none of the function can be called with the argument supplied. So this argument it is not taking as the name. So what we can do is we can put double quote. We can actually cut this entire thing, and we can put double quotes, and here we need to put a dollar sign also. So we will put a dollar sign here, and then we need another dollar sign because we are going to call the price, and we need this dollar sign to call the price because I think it's float and it's just not take directly like the name. So we will just say price, and we can actually remove this gap, otherwise there will be gap between the dollar sign and the price. So the next thing is this chart data. So for that we need to create another file. So for this chart data we need another file where we can create this function to show the chart data. So in the next lecture we will be building this chart data. So I will see you in the next one. So now we will build this chart. So it's called line chart. So we will build this chart. So let's start building our line chart. So for that we need to create a new component file, and we will call it chart or charts, and it's going to be a file. So here we will say at composable, we will say function line chart, and it's going to require some fields or properties. So first we need a modifier. So we will say modifier of type modifier, and we can set it to modifier. Then we need colors, line colors for drawing the lines. So it's going to be a list of two colors. Both of the color will be same. So we will say line colors, and it's going to be a list of colors. So we will say list of type color, and then we can say list of, we need to import the color. So we will choose the compose.ui.graphics color, and then we can say list of, and we can provide two colors here. So basically both of the colors will be same. So we will say material theme dot colors dot primary, and for the second color we will use the same color. Let's get a little bit of more space, and the next property will be line width. So we will say line width, and it's going to be of type float, and we can set it to 4f. Then we need a y-axis, so we will say y-axis, and it's also going to be of type list, and it's going to be a list of values. So we will say list, and the typing will be float. Then we will have a boolean value for animation, so we will say should animate, and we can set it to boolean. So we will say boolean, and the initial value will be true because the line is always kind of getting updated time to time. And then we need another boolean value for drawing the live dot. So we will say should draw live dot, and we will say boolean, and that will be false initial value. And we need an animation key, so we will say animation key, and which is going to be of type any. So we will select any, and then we can say it's going to be of type, and then we can set it to unit. So we will say unit, and last property will be custom x target. So we will say custom x target, which is going to be of type int, but it will be converted to float when we will feel necessary. And let's open the curly braces. So we will say curly braces. So here we need to create a value for y-axis, and here we need a value for y value. So we will say value y val equals, we can set it to y-axis. Then we need a value for x, so we will say value x, and we are going to use remember function. So we will say remember, and for the calculation we will use the animatable function. So we will say animatable, and we need to provide an initial value for it. So we will say 0f, and we need to import the animatable. So we have actually already imported the animatable, so let's remove it and see if it can go on without this import. It's right here, but I don't know why it's asking to import again. Without importing it does not work, so let's just import it, and let's remove it from here, and let's try it again. Let's import this one and see if it works. So now it's working without the, okay, so in the beginning I got the wrong import, so that's why it was not working. So this animatable function creates a float value holder that automatically animates its value when the value is changed via the animate to function. So its specialty is that it supports value change during ongoing value change animation. Then we need a value for x target, so we will say value x target. So for that we will say if we will say if custom x target is greater than 0, the x-axis is basically the time frame. So we will say if custom x target is greater than 0, then we will say custom x target to float. So we can convert it to float. Otherwise we will say else yval dot size -1, and we will call it to float. So we need to set x-axis in a certain limit, otherwise this line will become very long. So that's why we need to set it to y value dot size -1. So we will say y value dot size -1. So for y value you can go up to like -30 size depending on your device width, and it will increase the length of x-axis, and it's completely up to you that how long you want this line chart on x-axis. It should not be too long. So I will show you the demo when the home screen will be ready for demonstration. So you can go for any value. You can even leave it to y value dot size and it won't make much difference. So it's completely up to you. So I am going with -1. And now we need to animate this chart according to data changes. So we will use the launch effect function. So we will say launch effect, and it requires a key. So we will provide our animation key here. So we will say animation key, and then we can open the curly braces, and here we will say x dot animate to, and it requires a target value and animation spec. So let's provide the target value. So for target value we can say x target, and we need an animation spec. So let's say animation spec, and for this we can provide twin, and this twin function requires the duration in millis. So we will say duration in millis or duration millis, and here we can say that if should animate. So if it's animating, then we will say 500 else 0. So the duration will be 500 milliseconds, which means half a second, otherwise 0. And then we need to provide a easing parameter. So we will say easing, and we can set it to linear easing. We need the easing property to ease the curve because the chart is never linear. It's constantly changing, sometimes going up and sometimes going down. So it will be used to interpolate between start and end. So after launch effect, we will need the infinite transition because the price change never stops. So we will say value infinite transition, and we can use the remember function, remember infinite transition. We have a typo here, so we will just remove it. So here we will use remember infinite transition, and then we have to define the radius. So we will say value radius by, and we will use this infinite transition value. So we will say infinite transition dot animate float, and here we again need to provide initial value, target value, and animation spec. So for initial value we will say 7f, target value will be 15f, and for animation spec we will say infinite repeatable. So it will keep repeating itself and never stop, and here we need to provide the animation for it. So we will say animation, and we can again set it to twin, and we can do the same things over and over again. So duration will is 500, easing will be linear easing, and we also need to provide a repeat mode. So we will say repeat mode, and we will set it to repeat mode dot reverse, and we need to import the runtime for get value. So we will just import it. Then we also need to set the opacity from start to finish, so the color will look a bit different. So if you look very closely, then you will find that here the color is a bit light and here the color is bit dark. So that's happening because of the opacity. So let's define our opacity. So here we will say value opacity by infinite transition. So we will use the infinite transition again, and here we will say dot animate float, and again you can set these values to your own liking, but the range should be between 0 to 1. So I will say initial value 0.7f, and target value can never go beyond 1f, and we need to provide the animation spec. So we will say infinite repeatable, and let's provide the animation for it. So we will say animation, I went outside, so here we will say animation equals twin, and duration will be 500, and easing will be linear easing, and also the repeat mode. So we will say repeat mode equals repeat mode dot reverse. And now finally we need to create the canvas, because the canvas is the one on which this line chart will be drawn. So let's create the canvas. So let's create our canvas. So we will say canvas, and let's use the function canvas, and here we will say modifier dot padding, and we can give it 8 dp of padding, and we can remove this on draw function from here, and let's open the curly braces, and let's also remove this import. Then obviously we will have to import again, because I think we got the wrong import here. So let's remove the wrong import, and now we should be able to import the right one. So we need this function one canvas with the draw scope. So first we need to create a path for the canvas on which the line will be drawn. So we will say value path equals, we already have a pre-built path function in Compose, so we don't have to worry about that. So we can use this path function, and then we need to create bounds for our x-axis and y-axis. So we will say value x bounds, and we can set it to pair. So we will say pair, and we can set it to 0f to x target, and then we need to create y bounds. So we will say value y bounds, and for this we will have to create another function to get the y bounds. So let's create our function get bounds for y value or for y bounds. So here we will say function get bounds, and it's take a list as an argument. So we will say list of type list, and it's going to be of type float. The value is going to be of type float, so we will say float, and this get bound function is type of pair. So we will say pair, because the bound requires two values, so you cannot create a bound with just one value. So we will say pair, and then we need the types of those two values. So we will say float and float, because both of them will be float. And let's create a minimum and maximum variables. So for min we will say float dot max value. Okay, we need to import the float. We got the wrong float, so we will say float. We need the Kotlin one. Float dot max value, and we need variable var for max. So for max we can say minus float dot max value, so it will be opposite of min value. Then we can run a for each loop for our list, so we will say list dot for each, and here we will say min. So we are setting the minimum value, so we will say min dot coarse at least, coarse at most, and we can set it to itself, so we will say it. So what it will do, it will make sure that the value don't go beyond the set value, so it won't go beyond this float dot max value. And then we can set the max value as well using the same technique, so we will say max dot coarse at least, and we can set it to it, so it won't go below the least value or the value that we have defined here. And then we just need to return the pair. We will say return pair, and we can say here min and max. So now we can get the value of y bounds using this get bound function. So we will say get bound, and we will give it the value of y value that we created in the beginning, so this one. Now we need the dimensions of the current drawing environment, so we will need to create again value for scale x. So we will say value scale x equals, we will say size dot width, and we can divide it by using our x bounds dot second minus x bound dot first. And for scale y we can use the same technique, so we will say size dot height divide by y bounds dot second minus y bounds dot first. Then we also need a value for y movement, so we will say y move, and we can set it to y bounds dot first into scale y. We need the multiplier, the asterisk, not the dot, so we will say scale y. Then we need a value for interval, for the drawing interval, so we will say value interval, we can say 0 to minimum, so we can provide a minimum value, so we will say minimum, and let's choose the float one, so we will say minimum y value dot size minus 1, and for the second argument we can say x dot value to int. And then we also need a value for our last point on the chart, so we will say value last equal, so we can call the last function on the interval, so we will say interval dot last, and it will get you the last value. And then we need to run a for each loop on the interval, so we will say interval dot for each, and here we can create a value parameter followed by arrow function, and we can say value x point equals value asterisk or into scale x, and for value y point we can say size dot height minus y value, and we can provide the list of value here. So we will say value asterisk or into scale y, scale y. So we will say scale y, and then we can say plus y move. After that we can say if value is equals to 0, then we can say path dot move to, and here we can provide the x value and y value. So we will say for x value 0f, and for y value we can provide the y point, so it will be y point, and then we just need to return this for each. So we will say return at for each, and then here we will say path dot line to x point and y point. Then we need to create the function of draw path. So here we will say draw path, and here we will set the path to the path, and we need a brush to draw. So we will say brush equal to brush dot linear gradients, and here we will use our line colors that we declared in the beginning, and then we can provide a style also. So we can say style equals, we can say stroke, and for stroke we can say width equal line width, that is also we created in the beginning. And then after draw path we can finally say that if should draw live dot, so if it's true then we can say draw, then we can say draw circle, and here we will just say line colors dot first, and then we can provide the radius. So we will say radius, and then we also need to provide an offset. So we will say offset. So let's choose this one to provide the offset on x and y axis. So for offset we will say last asterisk scale x, and for y we can say size dot height minus y val. We need this into parenthesis because we have multiple calculations. So we will say y value, and then we can provide the last point or the last, and then here we will say asterisk scale y, and then here we can add the y move. So we will say y move, and here we can set the opacity. So we will say opacity. So that's it for the line chart. I know that this line chart was very overwhelming, but if you keep practicing and playing with these values, then we will understand it better. So I will see you in the next lecture. So now we can get back to our crypto list item. So here you see again in the image that we have again two datas, the line chart and the change in price and change in price percentage. So we can again create a column to fit those two components. So now we can create a column again to fit those two components. So here we will say column, and we can give it a modifier of weight. So we will say modifier dot weight, and this time we can give it a weight of 1f. So we will say 1.0f. And now we can bring in the line chart that we created in the previous section. So we will say line chart, and we need to set the y-axis. So for y-axis we can say crypto dot chart data, and we also need to provide a modifier. So we will say a modifier, and we need to set the width and height. So we will say modifier dot width, and we can set it to 100 dp. So 100.dp, and let's bring it to the next line, and for height we can say 50 dp, and we also need to align it. So we will say dot align, and here we will say alignment dot center horizontally, and then we can provide a line color. So we will say line colors, and here we will run an if and else statement. So if the price is going up, then we will set a green color, and if the price is going down, then we will set the red colors. So let's create the list of our green and red colors. So we can go to our UI package, and in this color file we can create our own colors. So we will create 3 variant of green colors. So we will say value green 200, and we can set it to color, and we will say 0xFF A5D6A7. So it will be very light green color. Then we have to make it a little bit dark. So let's say value green 500, and we will say color, and we can again say 0xFF 4CA F50. So it's a little bit of darker green, and then we need an extreme green color. So we will say green 700 color 0xFF, and here we will say 388 E3C, and we have a typo in our green color. Then we can create a gradient color using these 3 colors. So we will say value gradient green colors, and we can set it to list of. So we will say list of green list of, and we need to choose the second one element, and here we will say green 200, green 500, and green 700. So it will create a gradient color of green. Then we can do the same for red color. So we will say value red 200. For red we will only use 2 colors. So we will say color, and we will say 0xFFF 56040, and then we will say value red 500, and we will say color. So we will say color, and we will say 0xFFEE 1D and 52, and then we will say value gradient red color, and we will again say list of red 200 and red 500. And now we can get back to our crystal list item. So we will say line colors. So we will say if crypto dot daily changes is greater than 0. Greater than 0 means it's going up, it's in positive. So we will say gradient green colors, else we will say gradient red color. Then after line chart we have the text. So for text we will say text, and for text we will say crypto dot daily change. And because this crypto price is quite long in decimal, like up to 10 points in decimal, we don't want that. We want to go up to only 3 decimal. So we will create a utility to round off the price to 3 decimal. So let's create the utility function for it. So we will go to util package and we will say new Kotlin file, and we can call it formatter. So we will say formatter, and it's going to be a file, and here we just need to create two values. So we will say private value formatter 2, and here we need to set it to decimal format. So we will say decimal format, and we need to provide the pattern for it. So we will say double quotes hash hash dot or decimal hash hash. So this one is for rounding to 2 decimal, and the next value will be for rounding the decimal up to 3 decimal points, decimal values. So we will say formatter 3, and we will say decimal format, and for pattern we can say hash hash dot 3 time hash, and we have a typo here, so we will just add an R, and then we need I got the whole spelling wrong, so formatter. And now we just need to create two functions to convert the double into 2 decimal. So we will say function double dot round to 2 decimals, and we will set it to formatter 2, and we will say dot format, and we can just say this to string, and it's a function, so it requires the parentheses, and then we can do the same thing for the other one. So we will say round to 3 decimals, and here we will provide the formatter 3, and now we can use these functions to rounding the value. So here we will say daily change dot round to 3 decimals, and then we can add the second value, the percentage value. So here we will say plus, and we need to use the double quotes. So we will say double quotes, and we can use the parentheses, and here we will say dollar, and again we will use the curly braces to call our daily percentage. So we will say crypto dot daily percentage, daily change percentage dot round to 3 decimals, sorry, round to 2 decimals, round to 2 decimals, and then we can add a percent as a string, and then we can provide some styling to this text. So we will say style equals material theme dot typography, and here we will just say subtitle 1, and then we can also provide the color for the text. So here we will say if crypto dot daily change is greater than 0, then we will say green, gradient green colors, then we can say green 500. So we need to choose just one color, not gradient color, because it's the text color, not a chart color. So we will say green 500, else red, else we can use the We can use the ret 500, and then we need to align this text. So we will say text align dot center, and then we can finally add some modifier. So we will say modifier equals modifier dot fill max width, typo again, so we will just remove it, modifier dot fill max width, and we can align it to end. So we will say alignment dot end. So that was our column for line chart and the price text and the percentage text. Then we can create this icon, which will be given as a project in the end of the course. So I will tell you what it does at the end of the course, and I will give it to you as a project so you can learn some more on your own. So now we can create our icon. So after this column, when this column ends, we can say icon toggle button, and for checked we can provide the is fab button, is fab variable, and for unchecked we can run an arrow function. So here we will say has fab arrow function, and we can go to the next line, and here we will say if has fab then. So for now we can leave this as it is because it's for project purpose. So I will leave what it does to you, and we just need to provide the icon for this toggle button. So here we will say icon, and we need to choose the image vector, and here we will say, for now we will just say icons dot default dot favorite, and for content description we can say null, and we can also provide a tint value. So let's go to the next line, and here we will say tint, and we will say if is fab. So if it's favorite, then we will say color dot red, else we will say material theme dot color on surface. So now we have completed our single list item. So we will add this list item in our home screen to fill up the entire screen with crypto data. So I will see you in the next lecture. So now we will get back to home screen and we'll create our crypto list. So let's close all of these files. Let's close also this and main activity, and we can get back to home screen. So here we need to create a crypto list. So we will say at composable function crypto list, and it's going to require some properties or arguments or parameters, whatever you want to call it, you can call it. So we will say paging items, and here we need a lazy paging items. So we will say lazy paging items, and we need to provide the type. So it's going to be of crypto type. So we will say crypto. Then we need a favorite cryptos. So we will say fab cryptos, and it's also going to be of type list of type crypto. And we need a scroll state, so we can scroll the list. So we will say list scroll state, which is going to be of type lazy list state. And now we can open the curly braces. So here we need a context So first we will create a context. So we will say context equals local context dot current, and now I can bring in the lazy column, the thing that I have been talking in the last few lectures. So I will say lazy column, and here we can provide the state to enable it to scroll. So we will say list scroll state, then we can open the curly braces and we can provide the lazy list scope, and here we need to say items indexed. So there are a lot of ways that we can call our crypto data. So we will choose this item index, which requires items of lazy paging items. So we will say item indexed, and here we can set it to, we can provide the paging item as an argument, and then we can run an inner function here, and here we can just say underscore and then crypto followed by arrow function, and then we will let this crypto to let inner function or inner block. So we will say crypto question mark dot let, and here we will say value is fab. So we will say fab cryptos dot contains crypto, and now we can bring in the crypto list item that we created in our last lecture. So we will say crypto list item, and we need to fill all of the parameters. So we will say crypto and is fab, and then we need to apply the loading state. So we will say paging items dot apply. So we will say when load state dot refresh, we will say is load state dot loading, then we can set it to item. So now here we need to create a lottie animation. So we will create that lottie animation in the next lecture. So I will see you in the next lecture. So let's create the lottie animation. So for that we need to add the dependency for lottie animation. So we will go to build.gradle file, and here we will say lottie animation, and we will just say implementation com dot airbnb dot android lottie compose, and then we need to provide the version for it. So we will say colon 5.0.3, and we can sync now. So the sync is complete, and we can create our lottie file in the utility. So we will say new Kotlin file, and we will say file, and we will say lottie animation. So here we will say add composable function lottie loading view, and we need context. So we will say context, and we need a file for it. So we will say file of type string, and we will say iterations, which is going to be of type int, and we can set it to 10. So 10, and then we need a modifier. So we will say modifier, we can set it to modifier. Let's open the curly braces, and here we need to create a composition. So we will say composition, we will say by remember lottie composition, and here we need to provide a spec. So for spec we can say lottie composition spec, and here we need to provide the file. We also need to import the runtime, so let's do that. And here we will say dot asset, and we need to pass the file. So we will set the file to the asset, and then we can say lottie animation. So lottie animation, and here we need to provide composition and progress. So for composition we can set the composition that we created. For progress we can remove the progress, and we can say iterations equals iterations, and then we can provide the modifier also. So we will say modifier equal modifier dot default size, default minimum size, so it will be 300 dp. Now we will create another function where we will use this lottie loading view. So we will say at composable function crypto loading view, and we can say context, and here we can call our lottie loading view. So we will say lottie loading view. For context we can say context. For file we will say crypto load dot json. So we need to provide this file as an asset, so we will just do that in a minute. Let me complete this function, and after that we can say modifier, and we will say modifier dot fill max width, and height will be 150 dp. So now we need to create an asset folder where we can paste our cryptoload.json file. So I think here we can go to new, and there is a folder. So folder, and we can choose the asset folder, and we don't have to change anything here. We can just set it to finish, and it require a Gradle project sync. So now we have our asset folder. So there you can see that we have our asset folder now. So now I just need to paste the JSON file. So I'm just going to paste it here. So you can find this JSON file in the resource section. Now we can get back to home screen and use this crypto loading view function. So here we will say crypto loading view, the function we just created, and for context we can set it to context, and then we can say when load state dot append, we can say each load state dot loading, and we can create an arrow function, and here we will say item, and here we will say crypto loading view, and we can again set the context to context. And here we have some error. So actually this whole function should be outside of this function. So let's paste it here, and it should be fine. So now that we have our home screen ready, so we will have to do some more work to get the data on our home screen. So I will see you in the next lecture. So now we will call this crypto list function in our home screen function. So after header we will say crypto list. So you can see that it requires 3 parameters: paging items, favorite cryptos, and list scroll state. So we need a reference to our view model. So we will say value view model of type home screen view model, and here we will say view model, and in this view model we need to provide the factory. So we will say factory, and here we will say home screen view model factory, and then we need to provide context. So we will just say local context dot current, and we can take this parenthesis to its own line, and then we need a functionality. So we can scroll down. So we will say value list scroll state equals remember lazy list state, and then we need a reference for our paging items. So we will say value paging items, and we can set it to view model dot get all cryptos, and then we will call a function collect as lazy paging items. So we will say collect as lazy paging items, and then we have favorite cryptos. So actually it's a bit confusing because it's not favorite cryptos, fab cryptos. So we can rename this fab cryptos. So we will just rename it by doing refactor. So here we will just say, instead of favorite cryptos we will just say cryptos. So for cryptos we will say value cryptos, and we can again get the cryptos from view model. So we will say view model dot crypto live data, and we can call a function observe as state, and for that we need a runtime for live data. So we will just add the dependency live data runtime. So we will go to build.gradle file, and here we will say live data runtime. So we will say implementation Android X dot compose dot runtime, and we can choose the runtime for live data, and we can sync the project. So now the sync is complete, and we can go back to home screen. So here we will say observe as state, and we need to choose the second one. So for initial value we will just say empty list. Now we can set these properties. So for paging item we will say paging items. We will use our value that we created here. For cryptos we can set it to cryptos, and then we can say dot value, and let's get to the next line. And then for list scroll state we can pass our list scroll state. So now I think that our home screen is ready to call in our main activity. So let's go to the main activity. So the home screen is already here. So let's add the permission for internet. So we will go to manifest file, and here we will say users permission, and we will choose the Android permission dot internet, and we can close it. It's a self-closing tag. So now I am going to run the app on my physical device because the emulator is slowing down my system quite a lot. So I will just run it on my physical device. So let's do that. So looks like we have some error. So let's see the logcat. So it says that base URL must be end in /. So looks like that I forget to put the / in the base URL. So let's correct that one. So we will go to our network file, and we just need to put a / here, and it should be fine. And let's run it again. So it's up and running, and you can see the Bitcoin and chart data, and the change in percentage, and price change, and change in percentage, and the favorite icon. So Yeah, it's looking quite good. You can see that we have paging available. So whenever I scroll down, you see that new chart prepare at that moment. So that's because of paging. So we can check it again. So you can see that, and you can try that on your emulator or your phone. So from next lecture, we will start building our detail screen. So I will see you in the next one. So now we will build the detail screen. So in this detail screen, we have the name of the crypto and its symbol and 1 day changes. Then we have our line chart and another bar chart. So this one is called bar chart. So you can see that it has bars in it. And then we have some statistics data, 24-hour high, 24-hour low, 24-hour change, and then volume, supply, and market cap. So now we will build the detail screen for crypto app. So let's start. So let's close all of these for now. And we will go to screens and let's create another screen. So we will say new Kotlin file and we will say detail screen. So here we need to create a composable function. So we will say at composable. Then we will say function crypto detail screen. And we need one parameter for crypto data class. So we will say crypto of type crypto. And then we can open the curly braces. So first thing we need is the scaffold. So we will say scaffold. And in this scaffold, we will have a box component. So we will say box. So box basically allow you to place components on each other. So we will say we need a value for scroll state. So we can scroll up and down. So we will say value scroll state. And we will set it to remember scroll state. Then we need to create the header. So first we will create this header section. So let's do that. So we will say here. So we will say here at composable function header. And it's also going to require the crypto data class. So we will say crypto. And then we need the scroll state. So we will say scroll state. Then we can open the curly braces. Here we need a context, local context. So we will say value context equals local context dot current. And then we can create a column. So we will say column. And we need to set some modifier. So we will say modifier equals modifier dot padding, and we will give 12 dp of padding from all sides. So we will say 12 dp. Let's import the dp. So what we want is that when we scroll up, this header section will go behind this chart component. So what we need is that we need to animate our header section. So let's do that. So here we will say dot alpha, and then we will say, and here we will say animate float as state. So we will say animate float as state, and it's require a target value. So for target value we can say 1 minus scroll state dot value divide by 150, and we need to put it in parentheses. So we will just do that. And then we need to say OAuthIn, and we can provide the two values. So we will say 0 for minimum and 1 for maximum, and then we can call the toFloat function. to convert it to float. So we will say to float, and then here we will say dot value. So in this column we need to create a row. So we will say row, and then we need to set padding. So we will say modifier equals modifier dot padding, and here we want padding from top. So you can easily see that there is a bit of gap here. So we will say top equals 20 dp, and then we can say text. So we will say text, and for text we will just simply say crypto dot name, and we can style it a little bit. So we will say style material theme dot typography dot h6, and we can give it some padding as well. So we will say modifier equals modifier dot padding, and we can give it some ending padding. So we will say 8 dot dp. So after the text, the crypto name, we have this icon, the symbol. So we will do that, and then we have price and changes, daily changes. So let's do that. So after text we can say async image, and for model you know the drill. So we will say image request dot builder, and this is where we need the context. So we will say context. Then let's provide the data. So we will say data, and here we will say crypto dot image, and then we can finally call the build function. So we will just say build, and we can also provide some modifier because we have to give it some size. So we will say modifier equals modifier dot size, and we can give it a size of 28 dp, and then for content description we can just simply say null. And now we need to get out of this row because we have both of our data, text and image. So we will get out of this row, and here we will say text for price. So we will say text, and we will put the double quotes and bring in the dollar and curly braces, and here we will just say crypto dot price, and we can round it to 2 decimal. So we will say round to 2 decimal, and after that we can put the text for USD, and again we can style it. So we will just say style material theme dot typography dot h6, and let's give it a font weight. So we will say font weight, and we will say font weight dot extra bold. You can choose whichever you want to choose. And then after this text we have another text for a daily change. So let's create the text for daily change, and here we will do the same thing with double quotes and dollar sign, and here we will say crypto dot daily change dot round to 2 decimal. Then we can give it some space, and we will add the daily change percentage. So let's go to the next line, dollar sign curly braces crypto dot daily change percentage, and we will say round to 2 decimals, and here we can put the percentage sign after the curly braces, and then we can also write here today, and then we can set the color depending on the loss or profit. So we will say color. So here we will just say if crypto dot daily change is greater than 0, Then we will say green 700, else we can say color dot red. So that's it for the header. Now we can call this header into our crypto detail screen. So the first thing will be header, and let's say crypto. So we will set it to crypto, and for scroll state we can remove this equal sign, so it will set to this scroll state. So now that we have started building our crypto detail screen, we need a way to navigate from home screen to detail screen. So there are number of ways in which we can achieve this functionality. So we can use navigation or we can use intent. So in the past course I have used navigation. So for this course I am going to use intent. So let's go to main activity, and in main activity we need to create a sealed class. So we will say sealed class, and we will call it interaction events. And here we need to create a data class for opening detail screen. So we will say data class open detail screen, and we need a parameter for crypto. So we will say value crypto of type crypto, and we can make it of type interaction event. So we will say interaction event. Then we need a function to handle the interaction event. So in the main activity we will say private function handle interaction event or events, and here we can say interaction event interaction events, and then we can open the curly brace. So in this function we will say when, we can run a when function, and here we will pass the interaction event. So we will say interaction event and curly braces, and we will say is interaction event dot open detail screen, and we can create an arrow function here, and we can say then start activity. Here we need to pass the detail activity, so we will have to create a new activity. So let's do that. So for that we will say new Kotlin class, and we will call it detail activity, and we need to extend it with component activity. So we will say component activity, and here we need to bind the crypto. So we will say value crypto by lazy, and then we will say intent dot get serializable extra, and here we need to pass the crypto as crypto. So for that we will have to make a companion object. So here we will say companion object, and we need to create a constant value. So we will say constant value crypto equals, we can name it crypto, and then we will say function new intent, and it requires a context. So we will say context of type context, and we also need to pass the crypto data class. So we will say crypto, and we can set it to intent. So we will say intent. Let's go to the next line. So we will say intent, and we can pass the context here again, and then we need to pass the detail activity. So we will say detail activity colon class dot java, and then we can say dot apply, and we can say put extra. So here we are putting the payload. So we will say crypto. We will put the constant that we created. So we will say crypto. So this is the name of the extra, and then we have to provide the value for it. So we will say crypto. Then we can get back to our binding, and here we will say, we will use the constant here. So we will say crypto, and then we can say as crypto. So that's it for the detail activity, and we can get back to main activity. So here we will say start activity, and then we can say detail activity dot new intent. So we are calling this new intent from handle interaction event. So new intent, and then we will say this, and then we can say interaction event dot crypto. So we are actually passing the crypto data class, and we have a typo here again, but it does not matter, but still we can correct it. So let's just refactor it. So I will say handle interactions, and that will be fine. Now we need to go back to our home screen to update our functions. So we will go back to home screen, and here we need to update the crypto list. So crypto list, and here we need to, so here we need to provide the event. So we will say interactions event, and here we need to say in parentheses interaction event followed by arrow function, and then we can set it to unit. Now we need to update our home function or home screen. So here in the crypto list we have to add another argument, because we have just created another parameter here. So we will say, so first we need to bring in the interaction event to the function home screen. So here we will say interaction events, and we can set this unit function to curly braces. So it will be like an empty function which can be used later. So now here we will update our crypto list. So we will say interaction events, and now we need to go back to main activity, and here we need to update our home screen also. We need to get a reference of our view model. So here we will say value view model of home screen. So we will say home screen model, and then we can set it to view model, and here we will say factory equals home screen view model factory, and we need to provide the context. So we will say local context dot current. Now we need to update the home screen in our main activity. So we will just do that. So here we will say interaction events, and now we can use this function that we defined in home screen. So here it's nothing, it's just an empty function, but now we can provide the functionality for it. So here we will say handle interaction events, and we need to pass the events. So we will say it, and we also need to pass the view model. So we will say view model. So we have an error, and it says too many arguments for private final function handle interaction events. So we need to create another parameter here for view model. So we will say view model of home screen view model. So actually we don't need this view model right now, but I am setting it up for the project. We can actually remove this one and this one, and it should work fine. So let's try run this app and see if we can get to our detail screen. So I'm just going to play run. So the app is up and running, and let's click any of it. Okay, we did not provided any functionality to handle the clicks, so that's why it's not going to the detail screen. So we need to go back to our crypto list item. So here, and we need to provide the functionality to handling the click. So for that we need to bring in the interaction event. So we will say interaction events, and we need this in parentheses, so and followed by arrow function, and then we can say unit. And then in the row where we have this clickable modifier, we just need to provide the function here. So we will say on click, and we will say interaction event, and then parenthesis, and we will say interaction events dot open detail screen, and we need to pass the crypto, and that's it. I think it should work now. So let's run it again. And here on the home screen we have to pass the parameter, and here we need to declare the parameter for interaction event. So we will say interaction event, and now we have to declare our new detail activity in the manifest file, because all the activity should be defined here. So we will say activity, and we will say Android name. So it's already able to fetch the activity, so we will just select it, and then we have to define a label for it. So we will say Android label, and we will just say crypto detail, and then we have to also provide a theme for it. So we will say style theme crypto app, and it's a self-closing tag. So let's close it, and let's run it again, and now we can click it again. So it's completely white. That's mean that we are not getting the crypto detail screen on the detail activity. So let's go to the detail activity class, and let's see what we miss. So here we forget to override the onCreate function. So let's do that. So we will say override function onCreate, and we need to choose the saved instance state, and we can remove the persistent state. We don't need the persistent state, so we can remove this one also. And now we need to call the set content function. So we will say set content, and here we need to call the crypto theme. So we will say crypto app theme, and here we need to call our detail screen. So in detail screen we have this crypto detail screen function, so we need to call this one here. So we will say crypto detail screen, and we need to set the crypto as parameter, and now we should run it again. So now you can see that we are getting some data on the detail screen. We can go back actually, and we can click on some other crypto. So let's click on this, and we are able to get the name and price change. So that's it for this lecture, and I will see you in the next one. So now we will build this second component, which has two subcomponents, the line chart and the bar chart. So we already have the line chart that we used for home screen. So we will build this bar chart. So let's start building our bar chart. So we need to go to our chart file. So here is the charts file, and in this file we can create a bar chart. So we will say add composable. So we will say function bar chart, and it's going to require some parameters. So first we will have modifier, then we need colors for our bars. So we will say bar colors, and it's going to be a list of colors. So we will say list, and we can provide the color, and it's going to contain list of colors. So we will say list of, and we need to choose the second option, and here we will say material theme dot dot colors dot primary, and we will choose the same color for the second parameter for the second color. So we will say material theme dot colors dot primary. Then we need to define the width of the bar. So we will say bar width. It's going to be of type float, and we can set it to 25f. Then we need y-axis value. So we will say y-axis value, and we will say list, and then it's going to be of type float. Then we have last parameter for animation. So we will say should animate, and it's going to be of type boolean, and we can set it to true. Now we can open the curly braces, and here we need two values, one for x and one for y values. So we will say value x, and we can set it to remember function. So we will say remember, and we will say animatable, and we need to choose the compose.animation.core. So we will select that, and we can set the initial value to 0f. Then we can create a value for y values. So we will say value y values, and we can again use remember function, and here we will set it to y-axis values. So we will say y-axis values. Then we need a value for x target. So we will say value x target, and for this value we will say y values size -1, and then we can convert it to float. So we will say to float, and then we need to animate the bars. So we need a launch effect. So we will say launch effect, and here we can pass our unit. So we will say unit, and here we will say x dot to animate or animate to, and then we need to provide some parameters. So we will say target value, and we can set it to x target. Then we need animation spec. So we will say animation spec, and we can set it to twin. Then we need to provide the duration in millis. So we will say duration millis, and here we will say if. So we will run a if else statement. So we will say if should animate. So if it's animating, then we will set it to 500, else we will say 0. And then we also need easing. So for easing we can say linear easing. Then we need the canvas. So after launch effect we will say canvas. So we need canvas to draw the bar chart. So we will say canvas, and we can give it a modifier for padding. So we will say modifier dot padding, and we need horizontal padding. So we will say horizontal equals 8.dp, and we can remove this on draw for now. We will define it later, and we can open the curly braces here, and here we need to create bounds for x and y just like line chart. So we will say value x bounds, and we can set it to a pair. So we will say pair, and we will say 0f to x target. So we need to provide two values for the bounds, and then we can do the same for y bounds. So for y bounds we will use this get bound function that we created when we are building the line chart. So here we will say get bounds, and we can provide the y values for it. So we will say y values. Then we need to measure the scale for x and y axis. So we will say value scale x, and we will say size dot width divide by, we will say x bounds dot second minus x bound dot first. So we will get the scale for x, then we will say value scale y, and we will say size dot height, and here we will say y bounds dot second minus y bounds dot first, and we need to divide it actually. Then we need to calculate the movement for y move, so we will say value y move, and we can set it to y bounds dot first into scale y, and then we need to run a for each loop for y values and x values. So we will say 0 to minimum, and we need to provide two values for it, so we will say y values dot size minus 1, and for x value we will say x dot value 2, we will say to int, and then we can run a for each loop, so we will say dot for each, and here we can create a value parameter followed by arrow function, and here we need to create an offset value for x and y, so we will say value x offset, and we can set it to value into scale x, and we need y offset, so we will say value y offset, and for this we will say size dot height minus, we need to provide the y values, so we will say y values, and we can provide the index, so we will say value, and then we can say into scale y, and we will say plus y move. And here we need a function to draw the bar, so let's create a function for drawing the bar. So we can get out of this function, and here we will say function draw scope, we need a scope for it, so we will say draw scope dot draw bar, and here we need to provide some parameters, so we will say top left, and it's going to be of type offset, so we will say offset, and then we need the width, so we will say width, and it's going to be of type float, and height also, so we will say height also of type float, and then we need a color, so we will say color, which is type of color, so it's a list of color, so we will say list, and then we can provide the typing, so we will say color, and here we will just say draw rect, and we need to provide some parameters for this function, so for top left we will say top left, and we need to provide a brush, so we will say brush equals brush dot linear gradient, and here we need to provide the list of colors, so we have already defined our color here, there is a typo, so we will pass this color, and then finally we need to provide the size, so we will say size equal, we can say size, and we will choose this one with width and height, so we will say size, and for width we will set to width, and for height we will say height. So now we can use this draw bar function in our for each loop, so here we will say draw bar, and we will have to provide the top left again, so we will say top left, and we can provide the offset for it, so we will say offset x offset and y offset, then we need the width, so we will say width and we can set it to bar width, and then we need the height, so we will say height, and for this we will say size dot height minus y offset, and then we can finally set the colors, so we will say bar colors. So offset is the movement actually, if you don't understand what is the offset. So when a point move from one position to another position, so to calculate it we use the offset function. So that is the offset thing, whether we are moving in y direction or x direction. So now we need to create another function where we can put together these two charts in one component. So let's create function chart in detail screen. So in detail screen we can say we need to create another function. So we will say at composable, and we will say function chart. Let's just say chart because we already have we don't have chart function. No, we don't have chart function, so we can call it charts. And again it's require our crypto data class, so we will say crypto, and then we can open the curly braces, and here we need a card view because this whole thing you see is a card, so both of these charts are inside a card, so we will create a card view. So for card view we can say card, and here we need some modifier, so we will say modifier equals modifier dot padding, and we can give it a vertical padding of 8 dp, and we can give it some elevation, so we will say elevation of 8 dp as well, and then we can provide a shape for it, so we will say shape, and we can say rounded corner shape, and we can set it to 4 dp. So let me show the rounded corners shape if you have not noticed it. So this is the rounded corner shape. Because it's only 4 dp, it's very hard to notice, but if you increase the size of rounded corner shape, then you can easily notice it. So you can set this to your own liking, and then we can create a column inside this card, so we will say column, and now we can bring in the both charts that we created, so we will say line chart, and let's start by giving it some modifier, so we will say modifier equals modifier dot fill max width, and we also need to set the height because we have two charts inside it, so we will say, let's go to the next line, and here we will say height, and we can give it a height of 100 dp, so 100 dp, and then we can provide this x-axis value. So let's go to next line, and for x-axis we will say crypto dot chart data, just like before we did it in home screen, and then we need to provide the colors, so we will say line colors, and we have done this before, so we will say crypto dot daily change is greater than 0, then we will say gradient green colors, else we will say gradient red colors, and then we can provide a spacer because we need to have some space between the line chart and the bar chart. So the line chart ends here. Let's also move it to next line. So the line charts ends here, so we can create some space by saying spacer, and we can give it a height, so we will say modifier dot height, and we can give it 10 dp of height, so we will say 10 dp, and then we can bring in the bar chart, so here we will say bar chart, and we need some modifiers for this one as well, so we will say modifier equals modifier dot fill max width, and then we need height for this one as well, so we will say dot height, and we can set it to 120 dot dp. And for y-axis value we can again say crypto dot chart data. So both of the datas are same in line chart and bar chart, just the representation is different. And then we need to create bar colors for it, so we will say bar colors, and we can create new color for this bar colors. You can see that it's a little bit purple color, so we will create a new color for it. So let's go to the color file, and here we will create a gradient purple color. So we need to create two values for purple color, so we will say value purple 200, and we can set it to color 0xFF or small f, and we will say 5851 dB. Okay, we already have purple 200. We can name it something else. We will say purple 300, and then we will create a purple 600. So we will say value purple 600, because we also have 500. So we will say color 0xFF 83 3A and B4, and now we can create the gradient color. So we will say value gradient purple colors, and we can set it to list of, we will say purple 300 and purple 600. Now we can set this gradient purple colors to our bar colors. So we will say gradient purple colors. So now we can call this charts function in our main crypto detail screen. So after the header we will say column, and here we need to create some padding from top, start and end. So we will say modifier, and we will say modifier dot padding, and we can provide the top for here. So we will say top, and I have a typo here, so let's correct that. And for top padding we will say 16.dp, and for start we will say 16.dp, and for end we will say 16dp. So we will have 16dp padding from top, start and end. And after that we need a scrolling functionality, so we will say dot vertical scroll, and we can set it to our state. So we will say state equals scroll state, and now we can bring in the two charts. So here we will say spacer to create a space between header and our charts. So we will say modifier equals modifier dot height, and we can set it to 200.dp. So you can see that we have quite a lot of space between the header and the chart component. So again you can set this height to your own liking. So after that we can say charts, and then for crypto we will just set it to crypto, and now we can run the app and we can see the progress. So now the app is up and running, and we can click on one of these. So there are a lot of spaces between these two components, so we can remove it to your own liking. I am going to just leave it like that. So in the next section we will build the last component, the statistics. So I will see you in the next one. So now we will build this statistics component. So it has two columns, one for containing these 6 components, and the other column is for these 6 components. So let's build our statistics function. So in detail screen we can go below the chart function, and here we will say at composable, and we will say function stats, and we need the crypto data class again, so we will say crypto, and we can open the curly braces. So here we need a custom modifier for bottom and top padding, so we will say value custom mod, and then we can say modifier dot padding, and here we will say bottom, and we can give it to 16 dp, and for top we will say 4 dp. Let's put it in same line. So the first thing is the text for statistics, so we will say text, and here we will just say statistics, and we can style a little bit, so we will say modifier equals modifier dot padding, and we can set the top padding to 24 dp, and for bottom we can say 8 dp. Then we can style it, so we will say style material theme dot typography, and we can set it to h5. Then we need a card, so we can put the 2 columns in the card, so we will say card, and here we will say modifier equals modifier dot padding, and we need a vertical padding here, so we will say vertical 8 dp, and we also need elevation, so for elevation we can say 8 dp, and we need a shape, so we will say shape, and we will say rounded corner shape, and we can set it to 4 dp. Then we can create a row, so we will say row, not row scope but just row, and let's give it a modifier, so we will say modifier dot fill max width, and let's give it a padding of 16 dp, so we will say 16 dot dp. And now inside this row we can create the 2 columns, so first column will be like column, and for modifier we can say modifier, and we can give it some weight, so we will say modifier dot weight, and we can give it a weight of 1f, so it will be uniformly distributed between 2 columns, so we will say 1f. And now we can put our text into this column, so we will say text, so the first text is 24-hour high, so we will say 24 high, or we can say 24-hour high, so it will be more understandable, and we can give it some style for typography, so we will say material theme dot typography, and we can choose the subtitle to, so we will say subtitle to, and then we need a value for it, so we will say, we will just copy this text and just paste it here, and here for text we will say we can remove this text, and here we will say crypto dot high, so it will get us the high value. And here for modifier we also have to round it, so we will say round to 2 decimals, and we can remove this style, actually we don't need the typography. And for modifier we will just set it to our mod value that we created, so we will say custom mod, so it will apply automatically, and then we can just copy paste for the other 2 components. So here we will say text, and here we will say 24 hour low, so we will say low, and here we will just say low, and then we can again copy and paste here, so we will say 24 hour, and here we can say change, and for this we will say daily change round to 2 decimal. So this is the first column. Now for the second column we can create another column here after this column, so we will say column, and we need to give it a weight, so we will say modifier equals modifier dot weight, and we can give it a weight of 1f, and then we can copy this text again. So I am going to copy all of this text, so it will be easier, and here we will say volume, so we will remove this and we will say volume, and for the volume we will say crypto dot volume, and we need to set it to string, so it will be converted to string. Then we have supply, so for supply we will say supply, and we can again set it to crypto dot supply, and then we have the market cap. We need to convert it to toString also, so we will say toString, and then we have market cap, so we will say market cap, and here we will just say market cap, and we need to remove this function, and we can also call the toString function here, so we will say toString. Now we can go to our crypto detail screen function, and after charts we will say stats, and we can set the parameter to crypto, and after that we need a spacer from the bottom to create some space, so we will say spacer, and we will say modifier dot height, and we can give it a value of 100 dp, so we will say 100 dp. We need this spacer so we can scroll up and can still have some space at the bottom after the stats. And now we can again run the app, so we will just run the app. So now our app is up, and we can click one of the cryptos, so we can click the crypto USD coin, and we have our statistic here. So that's it for this lecture, and I will see you in the next one. So guys, that's it for this class, and I have a project for you which will add some new functionality to this project. So what I want you to do for this project is to add a new floating action button and create a new screen for favorites, and add functionality for the favorite icon. So after adding the functionality, the favorite icon should add that crypto to favorite screen, and clicking again on the favorite button should remove the crypto from the favorite screen. So let's visualize this project. So this is our favorite icon for all the cryptos, and you need to create a floating action button, and you should place it here, and that would lead to a new screen called favorite screen. So whenever you click this icon, it will add this Bitcoin to favorites, and then you can go to favorite screens and you can see your favorite cryptos. Clicking again on that same favorite icon should remove it from the favorite screen. Also you can change the color of this favorite icon when it's added to favorite, so you can make it red or blue, and when you click it again it should go back to white. So go ahead and try this project and add as much functionality as you can, and I will see you in the next one. Goodbye and take care.